Okay, writing linear functions from context. I have quite a few example problems to kind of paint the whole picture of what students need to be able to do. So I'll probably break this video up into more than one part. We'll see. So problem 1 says total fitness gym charges $100 startup for the locker use and a consultation with a personal trainer. Now I just see one of those the mistakes where I have the word for twice. I'm just going to wipe that out. Never be afraid to admit you made a mistake. They charge $25 monthly fee for using the facilities. Okay, so part A says make a table and plot the graph. So I'm going to move this over a little bit. Okay, so $100 startup. So before you even start, you're going to pay $100. And then you're going to pay $25 each month. So you're going to pay $125, and then you're going to pay $150, then you're going to pay $175, and then you're going to be paid then $200, and then $225, then $250, and $275, and $300, $325, $350. Okay, so what is the initial condition? Well, $100. So that's what you initially spent, right? And that's sometimes designated with the variable b, or the parameter b. And the rate of change, which is sometimes called the slope, or m, is $25. Okay, so let's make the graph now. So $100 to start. After 2 months, you'll have paid $150. After 4 months, you'll have paid $200. After 6 months, you'll have paid $250. After 8 months, you'll have paid $300. And after 10 months, you'll have paid $350. Now notice I did every 2 years. I could have tried to estimate the values in between. And there I just did that. And there's my graph. Now, it probably should not have a line. It should probably just be discrete values. But if I wanted to draw a line, I could, maybe in a different color like red, draw a dash line, which is basically my trend line. And it can't go below 0, so I'm going to wipe that out so it doesn't look like it goes beyond there. Okay, so now write the model. So m of t, remember that's my total cost, is equal to 100. I'm going to use the dollar symbol, so it's not really a math symbol. 100 plus 25 t for time. So this was the rate times t, and this was the initial condition. Okay. From a math standpoint, what we usually do is we talk about equations y equals mx plus b, where m is your rate or slope, and b is your initial condition, your starting value, when x is 0. It's also known as the y-intercept, where it crosses the y-axis. Okay? So, let's look at another example. So, let's see, try and get it in camera. Let's see, an airplane 30,000 feet above the ground begins descending at a rate of 2,000 feet per minute. Assume the plane continues at the same rate of descent. The plane's altitude a of t and the time from the start of the descent are linear related. So it's a line, so it's going to have this pattern. So at time 0, at 0 minutes, it's 30,000. And then it goes down 2,000. So 28,000, 26,000, 24,000, 22,000, 20,000. And I could put in my commas to make it a little easier to read. Or I could leave them out. Okay, and the graph is already plotted there for us. You can see it has a negative slope, right? So this is a negative slope because it's decreasing. Okay, and what is the initial condition? Well, 30,000. And what is the rate of change? Well, it's negative, it's decreasing, so negative 2,000. So we'll write the model. Altitude A of t, they told us that up here, equals 30,000 minus 2,000 times t. So there's our model. Okay?